Welcome, everybody. My name is Colleen Forrest, and I'm the president of the St. Louis Space Frontiers. We are a chapter of the National Space Society, and our mission in life is to get people off this planet and not.
Hi, Christine, is the audio on?
Okay. Yeah, you get. Yeah. Okay. Can you hear me? Okay. So let me get this thing right there. Okay. So I think right now everybody should be seeing the. Yeah, the slideshow on the screen. Okay. And I think I'm slowly fading into my background here. I'm noticing up here too. Okay. Anyway, so we're going to Mars in 2020. There's going to be a bunch of missions going to Mars, and I always like this little shot here. If you notice, there's these little areas here in this rock that's kind of clean. And what this shot is, this is of one that I don't know if it was Pathfinder or one of the other rovers, can't remember offhand. But when we used to launch our rovers in balloons like this, or we had the airbags for the land in, this is the divots that when that rover landed. That's the impact the airbag made on Mars. And so, this is kind of like the marking of our beginning of our new age of exploration on Mars. I mean, you can kind of see where there's three divots inside of that hole, right there. And then it bounced and it landed here, and it bounced again. It landed way over here. There's another one back that way. But so we're going back to Mars again, and this time we're not alone because we have our own little version of a space race going on right now, which is this is a fun space race. It's not kind of like the other one. But we have, right now there's three missions going up in Mars. We're launching in July because that's when the window is to launch there. I'm going to show you about that in a second here. But China's going up, and they're launching on July 23rd. The United Arab Emirates is going up there. This is their first interplanetary mission. They've never even been to the moon yet, and they're launching up a probe to Mars. And of course, we're going with our lander and our little helicopter. Okay, so why are we going to Mars now? Why is all these people going at the same time to Mars? What's so special about now? It's called the Hoffman transfer window. And what basically it is that it's a time frame. So they got this guy over here. This shows it pretty good here. That you basically want to launch when. Oh, by the way, if anybody's looking for some really good STEM stuff to do with kids, the Jet Propulsion Laboratory has some wonderful stuff on this site here. You can just look up "Let's Go Mars" for JPL, and you'll find this site. But as you launch here, there's this little ellipse here, if you see that. And the idea is that you need to launch your spaceship when the Earth is at its closest point to the sun. And it's going to follow this ellipse, and it's going to run into Mars when Mars is at the farthest part from the sun. Now, if you remember on The Martian, when the Hermes was traveling on that one path, it just kept going around in circles from Earth to Mars. Well, this is basically the path it was following. It's following this its own orbit around the sun, basically. And it connects in both those places. So that only happens every 26 months where we can actually do this. Now, if we don't hit it just right, I love when you have graphics that work for you. Okay, so if we launch the wrong time, what happens is when we get to the top of the ellipse, Mars isn't there. And so there are other ways we can get to Mars besides this path, but this is actually the most efficient path because we're using the gravity of the sun and everything, and it gets us there. It's the best way to get there at this point in time with what we got. This is also how we got to the moon, and it was some of the math I had to figure out to actually get us to the moon. But now it seems kind of simple watching this diagram, but that was one of the harder things that we had to figure out back in the days. Okay. Let's get to the next stop here. Okay. And so you would think, okay, why isn't Russia and the European Space Agency going to Mars at this time? And well, they were going to go. they had a mission called ExoMars. There was a joint mission between ESA and Roscoe, which is the Russian space agency. And unfortunately, they also had tried a mission in 2016 that it crashed. And this particular mission was designed on the problem was the parachute coming down. It didn't quite open correctly. And this mission's parachute was designed off the same spacecraft as the 2016. So they had to we had to fix that parachute. And they weren't going to get it done in time for the 2020 window. So that's going up in 2022. Okay, so talking about China. Get that back in line. Okay, so China is sending a mission. They're sending the mission up. It's in kind of like a secret mission, but it's kind of like one of those secrets that everybody knows about. But they don't really, they haven't really released a lot of information on it. But it was kind of more the things that they're kind of worried about in case it didn't make it there, because this is China's first time going to Mars. And as we know, going to Mars is hard. It's actually landing, actually getting there. There's a lot of ships that that we've lost on the way to Mars, and we especially lost a lot on the crashing on Mars. And so this is going to be their first time going to Mars. So they're also sending the lander as well. They're going to be landing here in the Utopian base. This is kind of a little map of things. They're going to be landing here in the Utopian basin, and okay, right about here. And we're going to be landing. We're going to be landing right about here. So in the Jesuit crater over here. So I mean, they're kind of landing close to where we're landing, but it's not. There's nothing nefarious about them landing close to us, because that kind of stuff really doesn't happen in space. If you're going out there, people kind of got each other's backs out there. And for them landing here, if anything would go wrong with their landing, this being their first time landing, we're going to be looking at stuff over here. So our satellites are going to be going overhead, and they're going to be saving a little bit of money with because they're linking up with Argentina. There's a listening station out in Argentina where they're sending their information back to. And so if anything kind of goes wrong, they're going to get really, really good reception from our satellites going overhead watching our launch. Because we're going to be able to see exactly where they are, and they can find out what can happen if anything went wrong with their lander too that way, really, really easily. And okay, so the mission is basically, now they have released some stuff on the mission now that they're closer to the mission and they know that it's actually going to happen. But it's their first time going. They got this their little lander. It's very similar to the one they had on the moon just recently, and it's going to do a parachute landing. When it gets down there, it's going to have a rocket assist to kind of softly landing on the bottom. They're only planning for a 3-month operation. They kind of want to see if they can do that. But while they're down there, they're going to be doing, the basic stuff, the regolith sampling, the atmospheric surveys. They're going to look at the Martian magnetic field. And they also have a, first time anyone's done this, but they're going to have some ground penetrating radar. So they can actually kind of see, some of the subsurface features about what's going on there. So that's going to be kind of interesting. They're going to look at the permafrost underneath the ground. And, so they have a bunch of, they have some good equipment on there, and so hopefully it'll make it. The size of this vehicle, it's actually fairly large. It's about the size of a golf cart, so it's a fairly ambitious for going down for your first time going down to Mars. So, but we hope they make it. And this is the drop tower that they used to practice landing on Mars. And basically you have this little line going up here that helps you simulate Martian gravity. So as it falls down, they can kind of get some ideas of what what the shaking out and stuff like that. So they're working on getting their infrastructure together. But hopefully it can get down there, because one of the things they're looking for, and actually all these missions are looking for this time out, is things like, is there life on Mars, and was there life on Mars in the past? And if so, what if there was life? Were there origins similar to ours, or was it completely different? Uh, and could the current conditions that are on Mars actually support life now, if just with a little tweaks or something like that? Like is the soil actually conducive to plants? Stuff like that. And you also be looking at the ionosphere and, like I said, some of the internal structures of Mars that we haven't seen before. So if they get down there, there's going to be some good stuff coming back up. And this is a picture of their proposed Martian moon base eventually to have up there. And I like this picture here because it looks like we spotted this in the desert somewhere in on Mars. And actually, this is a tourist location. You can actually go there and visit if you want, once everything's settled down with COVID, if you wanted to. But they have it built in the middle of the desert, and they were using it with students to kind of get an idea what Mars would be like. But they also, it is also open to the general public to kind of come in and see. So it looks pretty cool. Okay, next one is this is the UAE's mission, and this mission is called Hope. It was named by this 13-year-old Indian student raised in Dubai. And I love this quote she has on here. It says, "I look at this event as a harbinger of positivity and optimism, not just for the UAE, but for the entire world. I am prepared to be enthralled by the findings and pictures that this probe will bring back." It's like you hear that statement, it's like, this is the girl is one of us, right? She's a space geek, she's hooked. And so look forward to seeing what she's gonna do with her future. But again, this is their first trip to Mars. They are not going down in a rover. And I want to say too about China. China is actually going to wait about 3 or 4 months before they actually launch the rover down. They're going to make sure the spaceship is actually in orbit and it's not going, launch, get there, and then land. It's going to be launch, get there, make sure everything is okay. And after a couple of months, then they're going to launch their lander. And so they're kind of mitigating their risk that way, that everything's going to be okay when they land the rover. UAE has their background in space has been basically getting some satellites up, and they had an astronaut on the space station. And then their next step was, let's send a probe to Mars. So it was like the little nation that could. They're going up with Japan. They're doing a JAXA launch. They've been doing a lot of pairing with JAXA. They've also been working with some of the universities in the U.S. They've been working with the University of Arizona, which Peter Swan is from, and the University of Boulder, Colorado, which I keep hearing great space stuff out of the University of Boulder. But so they have a lot of, they've gotten a lot of a consortium of getting the right people together to help them get up there, because they are really serious about exploring space and using it as their mission. And they also want to use this to encourage their young people to get into space. They are very adamant on that. They are also very making sure that they have women forward in their photos and everything like that. They're inclusive of women when they do their space program. Okay. And so this one, the mission that they're going to be doing is rather interesting, but because they're going to actually be getting a full year of data on the Martian atmosphere. They're going to get a 24-hour day, or not 24-hour day, but 26, a full day, put that way, of readings on what's happening on Mars, and they're going to get that over a full year. So they're just basically just concentrated on the atmosphere. They're trying to figure out, okay, why did Mars lose its water? And one of the things they're especially interested in is that there's a link between dust storms on Mars. We just had the dust storm coming through here. And if that had anything to do with why Mars lost its hydrogen and oxygen. A little bit because they're they're trying to see if there's a link there that has anything to do, because they want to bring that information on Martian climate. You can bring that then back to Earth and see how it applies to Earth climate. Because as we know, that nothing happens in space, happens in a bubble, and everything is always back and forth. What we learn out there, we can bring back here. What we learn here, we can bring out there. And so this is a really good example of that. So that they're doing a really good intensive atmospheric study, which is going to be some good information coming from that. And then this is their idea of a example space colony. I love the little conical building here they have on the outside. That's kind of a theme, I think, with space programs, having the conical building. Some kind of design. Somebody came up with a design for that, and everybody's been copying the conicals. But this is basically your airlock, and then they have a nice, really substantial brick wall. Like you would see desert construction having. It kind of reminds you of the old desert forts they would have in the days of the spice trade. And but this is actually an exhibit that they would take out like to like how we had the exhibits in the Science Center, and they take this around. They can take this around to different schools and cities and stuff like that, so the kids can come in, and they have like different little learning stations in here, like how solar works to work the power of the instruments and stuff. They have a section on the astronauts and what it takes, what they have to do to be healthy, both mentally and physically. There's a section in here on growing the food, and they also have a section on their rover, their orbiter, and what the mission is going to be about. So it's a really nice educational package they got together there.
Hey, Colleen.
Yes.
With all their atmospheric instruments, do you know if they're aerobraking when they get to Mars, or are they retro firing, or do you know how they're
that
doing
one?
it?
I don't know. Yeah, I'm going to assume aerobrake, but I mean I really don't know how they're actually injecting into the orbit. But they have like I said, they've been talking to us about how to do that. They've been talking to Japan and EAU. So yeah, that one I don't know, but we can probably find that out. It's a good question though. Okay, and now we're on our little ship here. Let's see, yeah. Okay, so this is the Martian rover, and our rover has its own rover, basically. Get you back centered here. Okay. So there's our little helicopter right there, and there's our rover in Perseverance, and this rover is about the size of a car, basically. So it's a bit bigger. It's built on the same package that basically that the other my mind is blanking. Our last rover that was up there was built on. The one that's up there right now. I keep want to say clairvoyance. I know it's not the name I know because of this. Yeah. Okay, but it's based on the same idea as that. It's also a nuclear powered machine. It's got a little packet of plutonium in there. And this little guy is going to ride up underneath here. And once Pathfinder lands, it's basically going to give birth to this guy. He's going to drop out the bottom here. And then the Pathfinder is going to roll away, give this little chance to charge up the solar panels. And then they're going to do some tests. Okay. So this is where we're landing over here in Zero Crater. And I can probably just do this right now. Okay, get this a little bit bigger. We'll get back there. Okay, come on. That's what I want to do. Okay, get that a little bit bigger. But this is where we're going to be landing. And you can kind of see, China was looking for a nice flat space. We were looking for a nice, interesting space. And this space has, a lot of river. There was I think this was full of water at one point, and then there's a lot of riverbeds that were flowing into this. So they think they can find a lot of good clays here, and if there was any life, this is where they're going to find it, because the kind of minerals that actually preserve that kind of fossilization they're going to find here. And so, so if anything, if there's any kind of life on Mars, this is where this is a very good spot where you'd find it. Okay. And we got a lot of. We're also looking in for if there was life on Mars in the past, if there's life going to be on Mars. And one of the cool things that one is going to do is a sample return mission. And how that is going to work is that Perseverance is going to go around and it's going to drill core samples into the Martian surface. It has about 30 of these sample bottles. It's going to put the samples into the sample bottles, and then it's going to leave the samples on its path on the Martian surface so that a future mission can come along and scoop those up and then bring them back home. The plan is, so that's, Pathfinder itself isn't going to do that, but eventually we're going to have, the next mission, or either in 2022 or 2024, the next mission that goes down there is going to pick these guys up and actually have a launcher that's going to launch from Mars and bring something back to Earth. But of course, the fun bit, let's see. Oh yeah, there's all the, it has, several instruments to do its on board, to do its experiments. So where's that one here? Okay. Yeah, this is an interesting one here. It's going to be different levels of light to kind of see if it can find some things in the atmosphere, basically, and see if it can actually find different markers of life that's on Mars. But this is the one we're all interested in here now. This is the Martian helicopter. Okay, I can see someone's happy there. Okay, this is Ingenuity, and yes, we have figured out how to actually fly a helicopter on Mars. I mean, it sounds like something out of a bad science fiction movie. That somebody who didn't know anything about physics would say, "Oh yeah, we can fly in an atmosphere that's 1% of Earth's." But actually, we can, and how they're actually doing this is to actually get this thing to fly. It's two things. One was give it a really long wingspan. So since they've got 19 inches on this off of this little thing, they've got the dual propeller here. That dual propeller. I don't know why I couldn't say that. Which actually, with the downdraft of the one, actually helps the lift of the other to bring it up. And then the angle of the swoop of the wing is actually at a very shallow angle. It's almost straight out, and to where other ones you'd have a little bit more of a bend to. But this has a much shallower angle, and that's how you get a helicopter to fly. They did some experiments with again, if you saw that drop tower that I had up there before from China. We had basically a similar. It was a drop tower inside of an environmental room, where they took out the atmosphere, got the atmosphere down to 1% of Earth, and this thing flew inside of there, and they were very happy about that. The videos are all over the place. If you want, I could try to find one on here for you. But it actually, so from all the experiments we've done on Earth, it flies. We don't know if it's going to fly on Mars yet, because it hasn't been actually on Mars. It's been on a simulated version of Mars, and there's still too many variables between that and what actually Mars is like to determine if it's going to fly. But they are going to do they're going to do some like really, really small tests. I mean, this is Wright Brothers stuff here. We're talking about 30 seconds in the air and then back down again. If they can get any kind of flight time in the air with this thing, this is going to be amazing, basically. But it's basically it's solar panel. I think they're going to be flying at about around like 11 a.m. They're gonna do some fly time, and it's gonna come back down again and have to recharge. They aren't gonna be doing too much exploration with this guy because again, it's experimental. The main thing they want to do with this is see if it can fly. But they're going to do some of the longer flights are going to be around 90 seconds. So, but they are going to try to see if they can get some good aerial shots with that. And so here's the equipment page on that. Yeah, because mostly what they got on here is they have a couple of some atmospheric sensors, as you would on any drone. Basically, this is basically a drone. But they have like some atmospheric sensors on there, and a camera, and an antenna to beam back information back to Perseverance. And it's basically going to fly around for a little bit, then land. Then they're going to go to the next spot, fly around a little bit, and land. To do that, they have to find a nice flat area inside that crater that's going to be about 10 meter by 10 meter space that they could use for an airport. And so they're going to be going, so one of the things that Perseverance is going to be looking for is that flat space where once they get there, they can see that it's a safe area to actually take off and land it. But so this guy is pretty neat. Okay. Okay. We're going to come back to him in a second here. Okay. Well, this is what our Martian habitat looks like, basically. So we have this great little, we have this great Martian helicopter going down and everything like that. And then when it comes to actually stuff that we have on ground, you kind of have, we're going to do this. These are the Martian analogs. People go in here and they try to live like they're on Mars and wear spacesuits and stuff. This is kind of based off of this. Of course, it has the conical shapes again. And this was actually what the Mars One idea of what they thought the habitats would look like. You have individual habitats, and with these little tunnels in the back where you would have your plants and stuff like that. And but these are all metal things, and NASA was kind of like, this is not going to work, so they had a contest. Okay, come on. Oh, God, wait till it does that. Wait till that green bar stops. Okay. And they came up, the winner of the contest had designed this little guy here. And this is a 3D printed building that you can basically build on Mars. And so you can basically launch this guy, your 3D printer on Mars first, have it build your habitats, and then go back and live in your habitats for a little while. They're using what we were talking about before is the basalts and a PLA sizing that was going to be made out of. Usually they have a plant on there for the PLA sizing, and I thought they kind of hedged it a little bit because they said, oh, you can use the plants from your that you're growing on Mars to make the PLA for the sizing, and the sizing is to make sure that the basalt, when you make the fiber out of the basalt, you don't want it to break. You don't want it to be too brittle. You want to have a little bit of bend to it. So you put sizing with the basalt, and when you make the fiber out of that, it's basically like basalt glass fiber. You melt the basalt to about 3,000 degrees. Yeah, add a little bit of that, and then you keep going around in circles until you make a tower. But so that's what their idea. And like I said, China came up with a tourist attraction. UAE had an exhibit that they could take around to schools. And this guy, oh, where did it go? There it is. Okay. This guy got an IndieGoGo account. Basically, they use the same equipment to build one of these things on Earth, and they started out with a couple of examples to where you could actually kind of go there in a vacation spot. They bought some land, or they made put a couple of these things out there. So if you want to take a vacation, you could vacation in a Mars home, basically. But they basically were showing like, yes, this is actually something. This is in vaporware. We can actually make these things. And if you wanted to, you can actually buy one of these guys. So, yeah. So they did turn it into a business. It's out there if it's a fairly inexpensive home to build, because all you're basically is just building this up here. And forgot how long it says it takes them to build it, but it's like to get everything inside of it like they have for actually living in there. I think it's about like a couple of months, maybe 2 months, maybe get it all together. But yeah, the name of the company is AI Space Factory. And if you can go out on their website and see what they got going on. But the main thing that this is going to be actually a viable technology is not so much this as it is this guy here, the machine behind it that's building it. The infrastructure has to be there to actually make the parts that makes the machine. And then you have to have the assembly to actually make these machines. So that's actually the make or break thing. It's not so much the structure itself as it is the machine that makes it once the structure has passed all the tests it needs to. And I think this shape here, I think, was dictated more about the limitations of the machine itself, because this is kind of gives you a big build volume inside of a 3D printer volume, basically there. And I was hoping to find like a Thingiverse version model of this out there somewhere, but I didn't find it. So I was gonna make a little one here, but I did not find the Thingiverse model, unfortunately. But when we do actually get up to space and we decide to Mars, this is more what we're looking at for a big base to look like. It's basically going to be a dome covered crater, and these things here, these are kind of like the rooms where people will actually be living. These are probably actually be covered with dirt and dust and loose stones and stuff like that to keep for the radiation. This guy here, you would think it would need more protection from radiation, but apparently it doesn't. Between the plastic and the space you have from the top of the roof to the bottom, and then the oxygen inside, the air inside is enough to actually prevent any radiation problems. Yes, yeah. We had one of the guys we had on Christina's talk was talking about that. But there's enough. They've done it the calculations, and that's all you need basically, because it's because of how far away the dome is and everything. But basically what space radiation is basically it's just particles, it's just electrons and protons basically hit, and then once they hit something, it stops. And so there's enough air in here, and enough so plastic is working better than glass. They're finding it's definitely working better than metal, because metal, when the radiation hits metal, you get these secondary radiation effects that happens off the metal. But you don't get those secondary effects off plastic. When the radiation gets to plastic, it basically there's enough there that the impact doesn't cause a secondary reaction. So plastic is actually better in space than metal, and rock is even better. So like the basalt they were talking about before is even better. Okay. All right. So this is a question that came up when I was talking about this at my church the other day, and I'm on the board. We're kind of like trying to figure out how to get back to meeting, and in the middle of it, somebody said, "And why are we going back to Mars?" And it's like, oh my gosh, don't get me started. I just, I don't want to have that conversation right here and pound in get in my soapbox right now, but it's a good question to answer. I mean, we have a whole bunch of stuff going on. There's, in the middle of a pandemic, in the middle of protests in the streets, we're going to Mars. Well, we went to the moon in the middle of demonstrations in the streets, 1968, 69. And what happened was we came going to the moon, we brought back the whole idea of, how precious the Earth was. And I think, it's just like you don't go waiting to things to be perfect. You go there learning how to be perfect, I think, because, there, like I said before, we don't have any of this people aren't going to the moon and trying to stab each other's backs, type of thing. We're going up there, even if we have, we go to space, even if we have conflicts on Earth, those conflicts go away when you go to space. Every nation has agreed upon that. Because, when you're out there, you need to help each other. We're not wanting, this is what it looks like. I mean, this is land that no one's been before. More importantly, no one's died on before. And it's like it's a place where you can actually go to where you're not taking it away from somebody else. There's no history of that anywhere. And
that we know of.
yeah, and we don't want it to be, that we know of. Yeah, I'll grant you that. There could have been that nuclear war that happened back way back, 200 billion years ago. But right now, there's no, that we know of. There's no one that we're taking this from. This is just there. And we can go there, and we don't want it to be like the Wild West. We want it to be like Antarctica. Basically, we're going there in a spirit of cooperation and of learning new things. And, as the fact that it is so hard to live there means you have to cooperate. The fact that it is, there isn't any air means that, hey, whatever air that is there, if someone's having trouble, you go to your neighbor, can I borrow a cup of oxygen? Everybody's got to have each other's backs. And I think, with learning, going there, because we are going, these are our footprints on the surface of Mars right now, that we need to go there with that. I think actually going to Mars will actually help bring back that spirit of cooperation back to Earth, in ways that we can't even imagine right now. So there's just a couple of more views here. I mean, it's an interesting planet. I mean, Mars has kind of its own look to it and stuff like that, but it looks like places we've seen. If you look at it as that little star in the sky at night, or even through the pictures of the planet from the satellites, it looks kind of strange and foreign. When you start looking at it straight up, close up, it's this is stuff we've seen. It's not that unfamiliar. And what we're going to do with it is going to be up to us. So, okay. All right, that is my presentation. Is there any? I think we had to three. Did pretty good. Okay, we did to 440, I think here. Okay, is there any questions anybody has? And I didn't turn on the chat. I don't know if there's been any chat questions coming up. Okay. Any other questions about the helicopter or anything? Really, someone look at that. Yeah, but I was gonna say, there are plenty of really, really good documentaries out there and how they made that helicopter and how that on YouTube. And I was just doing them justice in the time I had here was just like it's an amazing little machine. The fact that they actually thought that they can actually fly, somebody actually thought, let's fly a helicopter on Mars itself is, it just amazes me. And then they actually, okay, it's again, it's that idea of let's think it, then let's do it. And they did it. I think a lot of times people think that some of these ideas are beyond what we can do, and they're really not. If you let people, people have different, we have different people on the planet because we have different things that people do. The people are watching out, some people are watching out for this problem over here, and some people are watching out for that problem over here. Some people are, and we have different people so that they can work their problem, then we work our problem, and then we get all these problems out. uh I think that's kind of cool. I think, so while, like I said, people are working on some of these problems that we're having at home right now, we're going to be we're working on this. So someone's working on this problem. They figured out a helicopter on Mars. Okay.
Hey, Colleen,
Yes.
is the launch still being planned for July?
Yes.
Okay.
They were going to go on July 17th, but they're going on July 22nd now. There was a delay, but it wasn't a delay outside the window.
Okay,
Yeah.
got it.
Yeah, the
Thanks.
launch window that they have on there is from I can't remember when it started, but I know the UAE is going up on the 14th. That's the earliest one going up, and we have to August 5th to hit the window, and then the next one is 26 months away. So, but yes, the other thing too is how they figured out that orbit. Let me get back to here. This thing here. That's just really clever, actually.
It's a bang bang
Yeah.
orbital insertion style thing. So it's one of the easier ones to do.
Yeah.
Except
Yeah.
for the timing.
Yeah, that's the thing, is the timing. So the JPL site that I had up there earlier, they actually show you how to calculate that timing on there. So I said it's a really let's see if I can get that back down again here. So I think we only had till 4, but as long as they're gonna leave us on here, I'm gonna talk. Yeah, here we go. Okay. Yeah, but they actually go into here. If, like I said, if you have any, if you want, this is fascinating for me. It's it's geared more to high school kids, but they really go into actually how you can figure this out with basically a piece of string and a couple of thumbtacks. But you get this angle here, basically this is where we start out. Mars starts out there. It's about a 45-degree angle here, and by the time we get around to here is when it will land on Mars. So yeah, we're about 2/3 of our orbit around the sun when Mars gets halfway around its orbit.
If you're into orbital stuff like this,
Yeah.
Some of the most interesting transfers are the ones that are based off of constant thrust motors, like electric
yes.
motors and solar sails and things like that. And those are wacky. They're like these weird spirals that you gotta match one of the spirals just to the planet. It's kind of crazy looking.
That's pretty cool. Yeah, I mean, I think I've heard that a solar sail could actually get to Mars in 2 weeks, but it can't stop. And so, yeah, but yeah, no. If you want to talk about orbit sometime, Mike. Well,
I always want to talk about orbits.
yes, you're the guy. Oh, and speaking of which, there is another thing here. Like I said, that they had the lunar housing contest with NASA, and this is the latest contest that's out there right now. That if you're interested in that sort of thing, you can enter. It's the Lunar Loo contest, and they're basically looking for someone to build the next bathroom for space. They're looking for something that's going to work on both on Mars, Mars, the Moon, and the space station. So get your design hats on, and you can get into this thing. You can get into this project here.
And I have a patent on the high-speed centrifuge idea, so nobody take that one.
I was thinking about that too. Oh my gosh. Okay. Like a little bitty centrifuge in the bottom of the toilet that just kind of.
Oh, I was thinking the whole room.
Well, the whole room. Oh yeah. I was just thinking to just put it in the toilet and it'll just kind of like grab it'll grab it and take it to the bottom. But as I said, put your thinking caps on, people, because you might be the next winner of getting us out into space. So the important stuff that has to happen. I mean, it's like, I think we all realize the importance of going to the bathroom since the first thing that went away in the pandemic was toilet paper. Uh, so, okay. All right. Is
Thank
there
you so
anything-
much, Colleen. This was awesome. Awesome presentation.
Okay. All right. Well, thanks for joining in. And I think, so we hit our time limit here on there. So if anybody has any questions, I can answer them real quick. Oh, okay. There's Rick. You got something going on, Rick? Or you waving at me to say something, or are you waving at me to say goodbye? I can't hear you. You're on mute. Okay. Okay. Yeah. I can't. I don't know what. Yeah. I don't know why you're waving, Rick. I don't know if he was saying. I don't know if he was saying goodbye or if he was trying to get my attention there. Because it looked important. Okay.
Can I jump in and ask
Yeah.
Stanley a question that came up about Friday night's discussion?
Yeah, sure.
All right. Colleen, can you
What
hear me
about friction
I don't know what friction on what.
on the space conveyor, on the going, as you're traveling up and down? Somebody asked me that
Yeah,
later.
you said your nephew.
Yeah.
The friction between the rollers and the conveyor belt? Or what kind of friction?
Yeah. He just said, what about friction?
Well,
Yeah, Mr. Maybe.
the friction is holding it keeps the conveyor belt on the rollers. I don't know what other friction.
Okay.
You're talking about maybe the atmospheric friction.
Yeah, maybe
Well,
so.
yeah, there'll be a
Yeah.
small amount, just about the first, the troposphere, about
Okay.
the first 10 kilometers.
Oh, I think more.
There'll be some small amount of air resistance, but that's just a very tiny fraction of the length of the conveyor belt.
Colleen, can you hear me now?
Yes, I can.
Rick,
Okay. Is there any concerns about them launching the plutonium? I know a lot of times NASA gets heat from people worried the plutonium is going to blow up and get there.
Not that I've heard of.
Okay.
I mean, I think with everything else going on right now, people aren't thinking about that they're over launching plutonium.
Well, I know it's been a problem in the past. They've been worried
Yeah.
about, people getting
Mhm.
the rocket blows up.
Yeah. I haven't heard anything that they've been talking about it though, because so there's been the news has been
You got enough issues, yeah. Okay.
enough issues in the news. They haven't been.
Oh,
On
the
a slow news day, we probably would have heard a lot more.
I know they've had problems with the tires in the past. Supposedly these tires are supposed to be made better. They've had issues with the tires, right?
Yeah, it was the same. It's based basically on the Curiosity's tires.
Oh, but I think they've
Yeah.
improved them because they were getting punctured apparently by the rocks.
Yeah. Oh well, so the tires that did improve. I mean, the structure, the tires aren't actually were redesigned a little bit better, but
Yeah.
the rest of the structure is based on Curiosity.
All right.
And so it's only got like a year mission that they're planning for, but being nuclear powered, they can go a lot longer.
Is Arbison at WashU, is he involved in this too? Ray Arbison?
I do not know.
I know he's involved in all the other ones.
Yeah, I mean, I'm sure he is.
Okay.
But yeah, I haven't heard. I don't know if anybody else has heard anything.
I have a question
You're
about.
closer to that than I am, Rick. So.
I have a question about the helicopter.
Yes.
How high is the? I mean, it's just 1/100th of the pressure of Earth. How will that? I mean, on Earth, it's about the troposphere is about 10 kilometers or so. How high would the atmosphere be on Mars, that where most of the atmosphere would be?
Ooh, that's a good question too.
That is a good
Like, how high could the
Yeah.
helicopter fly?
Yeah. That I don't know. That might be one of the things they're going to try to find out too. But I know that they're only going up for 90 seconds. 90 seconds is going to be the longest flight that they're going to have.
Well, you got to figure the dust goes up pretty high. So
Yeah.
if we can propel that dust high in the air, it should be able to, the air can get that much thinner.
Yeah, that's a good point. If it can carry dust, it can probably carry this guy. I mean that to at least half of that area should carry it. No, they're also looking at these for other high altitude propellers with earthbound vehicles too. There's some of the balloon platforms that they're looking at putting up at about 130,000 feet. That they're looking at using these type of propellers for that too. So they can get
Are they
around.
also thinking of using balloons as like helium balloons or hydrogen balloons too?
Not on Mars, because on Mars, helium is actually way too much. The density of the air is actually less than the density of a helium balloon would be there.
Well, in the pressure, it's a lot lighter than carbon dioxide. So at equal pressure, it should still be lighter.
Yeah, but I mean, it's. I know when they looked at the balloons on Mars before, they had to do they had to have like the black balloons, like kind of like when we do like the air-filled balloons, the airbags that are black. The sun heats it up a little bit more, so it can fly in the daytime a little bit, and then when it gets to be night, then the air condenses and it comes back to the ground. It comes back to the ground again. And they were looking at something like that at one time, to possibly fly a balloon on Mars, but that's never actually, unfortunately, gotten off the ground, so to say. But do you know what I'm talking about? Did I make myself clear there? I mean, I'm thinking of what I'm thinking and just making sure all the words came out of my brain.
Okay, I guess it would.
Yeah. But when you have a black surface, the sun will actually heat the black surface up, and then that
would only be for using like hot air balloons. But if you have something lighter than air,
well, that even on Mars, it would actually needed that with the helium inside of there. Even with the densities and stuff like that, that's what gave them enough lift and everything else to go with that, because you're still having to displace the weight of what you're carrying with the balloon.
Yeah.
The density has to displace the same amount of weight to make buoyancy work. So it wasn't, as far as the practical size of a balloon that could disperse that much air and stuff like that, they had to have it. I think they were looking at the sun warming it up and getting a little bit of help from that. So now you go to Venus, that's a different story. Yeah, Venus balloons are cool.
Yeah, it's kind of hot there. I wouldn't.
Yeah,
go
I think it's at about, I forgot how far it was. How many miles above the surface of Venus that it actually, the temperature is there's a sweet spot in Venus's atmosphere that the temperature is about 70 degrees and pressure is the same as Earth air pressure. And you can actually float a balloon full of breathable Earth air in Venus at that atmosphere.
But if you go up or down,
yeah, if you go up or down, you're a little, if you have a leak, and there's some plumes that come off of Venus too that you gotta watch out for. But so I mean, it's possible to do, but there's some. It's not as simple as it sounds. But yeah, so those are some of the cool things that are out there. Okay. Any other questions or?